Welcome to another episode of TimeXtender Tuesdays. Today we're going to be talking about importing large tables. Now, if you've worked in TimeXtender for long enough, you've probably encountered a scenario where the data set that you're trying to ingest is pretty large. We're talking about millions, hundreds of millions, or billions of rows. And what you can run into in this case is a lot of different issues. Starting with timeout errors. Of course, you can always increase the timeout, but at a certain point, there are other issues that can come about. Any type of error or issue with the data in this process, when you're trying to load a very large data set all at once, it can cause the entire load to fail. And so what you end up with is, a large load that lasts over the course of hours or even days that all fails all at once. And especially when you've waited for that amount of time loading a data set, it's very frustrating when the entire load fails. And so the process that we're going to be talking about here is splitting up that load into smaller, more easier to consume segments. So we're going to go through the process of how to do that in TimeXtender. The data set that we're going to be using is a data set that's provided by Microsoft. It's available in Azure. It's CitySafety data from across many different cities in America. It goes over like 911 calls and different calls like that. And it's a fairly large data set. I think it's over 50 million rows. So we're going to use this data set, and we're going to connect to that using a Synapse Serverless SQL pool. So we're actually going to be looking at a couple things today, which is number one, how to take this data set and ingest it, break it down into smaller, more consumable sections. But also, a cool bonus, side bonus here is looking at using Azure Synapse Serverless SQL pool as a data source to connect to an Azure blob storage. So we're going to be looking at that as well. Well, let's go ahead and get started first and foremost by adding our data source in TimeXtender. So let's open up TimeXtender and of course go right in here to data sources and add a data source. Okay, we're going to give this data source a name. I'm just going to call it serverless. Okay. And we'll click next. And for this data source, I'm just going to use the TimeXtender SQL data source. The beautiful thing about Synapse Serverless SQL pools is that it essentially all it just requires is a SQL connection. And then once you have a SQL connection, whether that's through Management Studio or some other tool, you can write whatever queries, and the serverless engine computes those queries without any storage involved. So it just passes these queries down to, typically it's some form of Azure storage, whether that's a data lake storage or blob storage. So I'm going to put in the server name here. So if you want to learn more information about how to use these serverless SQL pools, there is going to be some links to our knowledge base where I talk about that in a couple of different articles. And so take a look at the description in the video and you'll be able to find those links to those articles and read more about this. And then I will put in the database name here. One important thing is by default, the Synapse Serverless just has a master database. There's a lot that you cannot do in the master database. So you have to create a database in that serverless SQL pool rather. So you create a database, even though there's no storage involved, it is an engine that maintains views and things like that. So go ahead and create that database as well, and you can use that when adding the data source. So I'll go through here and see if I can select any tables that I need. But this database for myself right now doesn't actually have any tables. So I'm just going to say all tables in the data source, and I'll click next. I'm not going to add a transfer task right now because we need to find out what data we want to bring in. Okay, I have my serverless SQL pool. Now I can use that to start running queries. All right. So the first step, now we've added the data source. Let's go back to our slides so we know what the different steps are in this. So we have a large data set. We want to break this data set into smaller, more consumable segments and load it over time. The first step here is to just review the data set, review the table, take a look at the table, understand it. So that's the first thing that we're going to do right in here. And we can do so right through TimeXtender. So I'm going to right click on this data source and click on the query tool. Going to go ahead and open that query tool, and I can just start writing in T-SQL right against that query. Now, instead of you guys having to watch me fiddle around with SQL, I have some of these queries already prepared so we can get through that nicely. So the first thing I'm going to do is I'm going to use this open row set function in the query to query a blob storage. So you can see this is Azure Open Data Store, blob.core.windows. This is an Azure blob storage. Azure's made this data set public, so no security is required, and I can just start querying that data set directly. So this is looking at multiple cities. You can see an asterisk here. So it's looking at multiple Parquet files across multiple different folders in this data lake. You can use these asterisks to query multiple different files. Again, there's going to be more links in the description about this if you want to learn more. And then you can use this file path function to actually reveal what is behind each and every asterisk. So for this one, it's finding the first asterisk and it's going to reveal what's behind there. So I'm going to go ahead and query this to find out what is in this data set. Take a look at it. It's important to analyze the data set so you can start to look at how you might be partitioning this data set and breaking it down into smaller sections. So we have this column 1, it looks like that's different cities. So I'm actually going to call that city here as city. And then I have here, we have data type, subtype, a date time. That's going to be important. We might be able to use dates to partition the data set. We also have categories, subcategories here, addresses, and sources. Okay, great. So a couple of different ways that I might want to break this down into different partitions. I can use that. So I have that. What I'm going to do to make this easier for myself, I'm actually going to create a view in Synapse that essentially matches this data set. So I'm going to go ahead and create that view. And then I can just, instead of having to use this whole function here every time, I can just call that view out instead. So I'm going to create a view for DBO CitySafety as still using this file path, so I can call that city, and then just about everything else. So I'm going to go ahead and execute that. And again, we can do this all directly through TimeXtender, which makes it really nice, really easy to get connected and start just querying data that's available in a data lake. So once I've created that view, let's go ahead and see how many rows we actually have available in this table. Or this view, rather. See how many rows are in there. All right, so quite a lot here. All right, so 824. So that's 49 million. So we have 49 million rows, almost 50 million rows in this data set. We need to figure out how we want to break that down. So let's first look at breaking this down one way or another. Let's try city. So I created that partition or the file path, right, that looked at the city. So I created a column in this view that's called city. So I'm going to group this by city, and let's see what the breakdown of row counts are by folders in the data lake. So here we have what looks like 19 million, 7 million, 11 million, 28 million, 1.6 million. So you can see that these groups are pretty the row counts vary quite a lot. It's not a very even distribution. Because of that, it's probably not going to be a great partition scheme for us. So let's try and take a look at another partition scheme. Maybe we can use the dates to break down these row counts here a little bit more evenly across. Let's try to look at date. So we're going to do select top 100 year as year. We're going to group by year. So we're going to count how many rows are in each year looking at that date field. So let's go ahead and execute that. Okay, so this is broken down by year. We see we have 1.7 in the year 2022, and then about close to 6 million, 5.3, 3.8, 3.8, 3.6. So a much more evenly distributed amount of rows if we look and break this down by year. And 5 million rows should be a decent amount for us to bring in at a time. So let's go ahead and use this distribution. I like this. This is a good breakdown of rows for us. So we're going to start first with the year of 2022. That'll be our first partition that we're going to bring in. And then we'll work on later partitions. But I'm going to go ahead and save this data. It's always good to save this information so we can use it later. I'm going to just paste this into an Excel spreadsheet. All right, and then I'm just going to go ahead and paste that data right in there. So I'll have that available to look at later. Great. So I'm going to go ahead and close. Actually, I don't even need to close this. I can just move it to the side right now. But I do want to identify that very first partition. I created a view recently, so I'm going to synchronize to take a look at that view. And then I make sure I can signal my incremental load rules on that view. It's very important, especially for large data sets like this. It's not required to do this. You can still break these partitions down even if you don't have a way to incrementally load the data, if you don't have this incremental field. But in my case, I'm going to do table contains CitySafety and column equals date time, like that. And I'm not going to do updates because this data isn't updated. It's just new data constantly being brought in. Go ahead and hit refresh. Always want to do that to make sure that the rule will get applied on the table. So it found the table and it says, and it found the field, says, okay, this is the rule I'm going to use. So once I get this going, I'm going to refresh this at least once a night, and then it's going to, gradually bring in new data as it's made available in there using that date time column. So we'll click OK. Now we've enabled incremental load. That's great. The next thing I want to do on this view, I want to filter rows on this view. This is going to be my core table, right? And I'm just going to say, let's just bring in everything after from 2022 and after, right? So the table contains, and I'm actually going to do table equals CitySafety, right? And I'm going to add a column, and again, that's date time, and the value is going to be greater than, I actually have this over here instead of typing that in. So 2021, December 31st, 2021, and that's at basically right at midnight. Okay, so this is just before the end of midnight. So this is saying bring in everything from 2022 and after, right? So TimeXtender will just be looking at that data, and it'll continue to do incremental load on that data. So I'm going to go ahead and click OK, refresh. Okay, and it looks like we have that rule now, CitySafety, that row filter. So it's only going to be bringing in rows for this instance of the table from 2022 and on. Okay, so this is the first step, right? Let's go back to our slides so we know. Here we go. So that's first step is reviewing the table. The second step is loading that first partition. So we filtered rows and we enabled incremental load. So we want to now go ahead. I'm going to create a task to load in that very first partition. All right. So let's go ahead and add a task. I'm going to add a transfer task here. We're going to call this CitySafety recent. So this is loading in recent data. I'm going to select the tables. And I'm going to say, okay, for CitySafety, go ahead and include this table for this task. And I can also schedule that. Remember, I want to do ongoing incremental loads every night. And again, once I'm doing incremental loads, I have this data loaded in. I don't have to worry about these massive data quantities because I'm just loading in every day, which likely just be less than a few thousand rows every time. So that'll be much quicker. Click OK, we'll finish that up. Now we have a task connecting to that data set, only bringing in the most recent data. So this first execution is going to run a full load of that 1 point something million rows. Okay, so we have 1.7 million, but it'll continue to do incremental loads on that data. So I have my most recent data and I'm bringing in new data. That's the most important step, right? Because now I can start working on the data. I don't necessarily need all the data to start building my data warehouse. I just need the recent stuff, and then I can start working with it and validating a lot of that data. So now what we're gonna do, the next step in here is to start loading these earlier partitions. All right, so let's take a look at this. We're going to do this using query tables. So we're going to create query tables for each partition that's selecting just the data that we want to bring in. So what query tables do is it essentially creates another view of the data. It's essentially a view. It's like a new table. So when we bring that into the data lake, it's going to look like a different table. They're going to come in as different tables. But then when we go to the data warehouse, we're going to map them all to a single table. All right, let's go back to TimeXtender. Let's go ahead and manage query tables, and we can start creating those partitions. So I'm going to add one here. We're going to call this CitySafety underscore 2021. Because remember, we're bringing everything from 2022 and on. And I'm going to go ahead and I have my query right here. So select star from CitySafety where year is equal to 2021. Easy enough, all right? So that becomes pretty easy. We are not having a subquery in here, so I'll go ahead and just add another one. Yes, and we'll again call this CitySafety underscore 2020 and use 2020 and so on and so forth, right? So we keep creating these to create all of those different partitions. Now again, we don't have to do all of this all at once. We can do it over time. It might take a little while to get data loaded in. Again, it's just historical data, so we can bring this in as needed rather than having to do it all in one motion. But if you do need all the data, this historical data, then you'd want to go in, create these different query tables, and then we can load them all in over time. All right, so what I'm doing again is taking this data set, breaking it down into smaller segments using query tables, and then we'll load these in to the ODX. One table or one partition at a time rather than trying to load one massive 50 million row table at once. So I'll click OK. Okay, so that's synchronized, completed. Now I can take a look at the Data Source Explorer and make sure that these new query tables have been recognized. So let's take a look. Good. So I have not only the original view I've identified, we have incremental load and data selection set up. That's good. And then we have here my different query tables. So we have CitySafety 2021, 2020, and 2019. Now it does look like query table or data selection rules are also applied there, which shouldn't be the case. Let me go to filter rows. No, it's just applying to CitySafety. This should not apply to those other ones because we are doing table equals CitySafety, not contains CitySafety. So we should be good. Okay, so the next step is to add transfer tasks for each one of those query tables. So I'm going to create transfer tasks. We're going to say city safety underscore 2021. Just like we did with the query tables, I'm going to select tables here. And we're going to do 2021 and include. Great. We don't need to schedule it because really we should just need to run this one time. Once we run it once, we should be fine, right? So we could schedule this to run at a later point in time if we wanted to say, well, I don't want to worry about dealing with this right now. I'm going to have this run once later tonight. And you can just say, well, I'll have it go overnight and I'll check up on it in the morning. So we can say, well, go ahead and run this later tonight. In this case, I'm just going to go ahead and run them right now. So I'm going to hit execute. I'm going to add another task while that's running. CitySafety 2020. Again, select tables. Select 2020, include that, hit next. Finish, and go ahead and execute. Now, the nice thing about TimeXtender in this case is that no two tasks can run simultaneously in a single data source. And so you can essentially queue these tasks up. So because this is running, I can just hit execute, and this will be then pending, right? So this is pending. It's waiting for this to finish. And then once this finishes, then it'll kick off my next task. All right, again, I'm going to load in the 2019 partition now. Select that 2019 partition, include that, finish that up, and again, I'll go ahead and execute that task as well. Okay, so we have our tasks running. While that's running, let's go ahead and take a look at our steps here. We created those query tables. We created the tasks and we scheduled those transfer tasks. In my case, I'm just executing them now, but you can schedule them to run at a later point in time. If you have a lot more data, maybe you might want to do one partition a night or something like that. It's always important to test and see how long is it actually going to take to load this data. Sometimes you won't really know until you start loading that first data set. And then the last step here is to synchronize tables. So we want to map all of these tables into a single table in the data warehouse, essentially doing a SQL union. So we can go ahead and do that now. So I'm going to open a project here. Okay, so I have my data warehouse open. I want to go open the data selection pane for the ODX. I'll just bring that right over. I always like to put them on top of each other. I think that makes a lot of sense. We want to find our serverless data source here, hit search, pull up the list of tables. And here I have CitySafety. So I can just drop that in. You take that initial data set, right? That'll create the table with all the columns. Now all of these other tables are going to have the exact same setup. So I can just simply drag and drop them right on top of my existing table. I can even select more than one, right? And just drag and drop them all onto the same table. So say I have 15 different partitions here. You just click and drag all of those and you map them all into the same exact table. So now we're going to be incrementally loading this newest data. And then of course, this data here is just going to be in there, properly loaded and landing in there. So we have now essentially created these different partitions, the tasks, we're loading those into the ODX. And then we've now unioned all of those different data sets in our data warehouse. Now, technically right now we are done with loading this data set and covering the topic of loading these large tables. But we do have an opportunity in front of us here. Because we're using serverless and our data source happens to be in serverless, we can talk about a pretty interesting concept. So it does require, in this case, it requires that your data source is in Azure storage, your ODX storage is also using ADLS Gen 2, and you're using a Synapse serverless compute engine for the data source, right? But what we can do is we can create a view that dynamically looks at the ODX data and looks at the source data and selects the data in the source based on what's available in the ODX. This is what's known as a rolling window. And this way, we don't have to go in and create all those views and all those tasks. We can just create one that the view dynamically updates based on the data that's being brought in to the ODX. So let's go ahead and do that now. I'm going to create a new query table. And in order for this to work, you do also need to create a what's known as an external data source and a scoped credential. And so what I'll do is I'll go ahead and open that up for you so you can see that. Here we go. New query. That scope credential, again, I'll put the links in the description here, but creating your scope credential is going to look somewhat like this. And then you'll want to create what's known as the external data source. So I've already done this on my side. I'm not going to run these queries, but creating an external data source, this is pointing to my ODX server, my ODX storage, which is a data lake container. And I'm calling it ODX, right? So I'm creating this external data source with a scoped credential. Once you have that done, you can run queries like this. I'm going to go ahead and copy this and open that up for you. All right. So for example, this one, select minimum date time from my ODX CitySafety data, right? And I believe this is called CitySafety. And I'm going to go ahead and run this query, make sure that's working okay. So you can see it's able to query the ODX and find out what that minimum date is. So now I can use a query like this, select top 5 million from this table, CitySafety, right? And I don't need to actually specify this file path because, again, that's already in the view. So select top 5 million star from CitySafety where date time is less than the minimum date time here, and the ordering by date. So I'm just going to go by date, select the next 5 million rows back in history. So I'm going to go in reverse chronological order and just load the next 5 million rows in. So I'm going to create this as a query table. So we'll go in and set up query tables. Okay, I'm going to add a query table. I'm going to call this CitySafety rolling window. And I'm going to go ahead and paste that in. You can see here it's select top 5 million or CitySafety. So we know it's just going to go 5 million and 5 million and 5 million, right? It's just going to load in 5 million each and every time. And when it does this, right, after it's done, it's going to, the next time, requery the ODX, right? Look at that minimum date, in which case it'll be less the next time, right? And so it'll just load in and again, complete that rolling window for us to make that a lot easier. This way, we don't have to create all these different views and queries and tasks. We can just create a view that dynamically selects the next 5 million rows back in history. Now, in this case, we're only able to do this because we're querying using serverless, looking at our destination, which is a data lake, and our source, which is also a data lake. So I'll go ahead and click OK, create that. We would simply add that in a task as well. I'm already transferring these other tasks, so I'm not going to do that. But then you can just schedule that task to run every night, right? So every night you're going to bring in the next 5 million rows, and the next 5 million rows, and the next 5 million rows, so on and so forth. So that's going to create a nice procedure for you. Again, you don't have to create all those views. It's a lot more automated. So there we go. That was how to bring in large data using TimeXtender. I hope you enjoyed this episode of TimeXtender Tuesdays, and look forward to seeing you next time. Thanks so much.